Okay, now we are going to learn about the elementary transformation of a matrix. So we'll consider a matrix first and then learn about the three rules. So maybe one example I'll take a smaller matrix. Maybe 1, 2, 3, 4 is going to be the matrix, and I need to consider the three rules. So there are three rules when considered to either a row or column. So first of all, we need to know that these elementary transformations are done when it is going to be in a equation of a matrix, and it is based on finding the inverse. Inverse is going to be the next part. So for finding the inverse, you are going to use this. So whenever you find the matrix multiplication is a binary operation, you are going to find the inverse of that, and its identity element is going to be I, and so on. We are going to step by step we are going to do. So for finding the inverse in such a statement, so we need to have some operations. Otherwise, all the elements are so many. So you have 1, 2, 3, 4 as 4 elements are present. How can you convert it into identity matrix and so on? So find the inverse. So in the first case, the rule says that you can interchange any row or I can interchange any column. Okay, I can interchange any column. So I can mark it as a number here, maybe R1, that is the row 1, and row 2 I am going to interchange, or I can write the column 1 that is going to interchange with the column 2. That is the first one. Okay, the next one is you are going to multiply that thing with some other. So if I consider Ri is the general, so you are going to transform it into K times Ri, or I can write it as Ri is going to change K Ci, right? Ci is going to change to K times Ci. Okay, that is what you are going to find out here. That is the thing, that every element that is present in that row is going to get multiplied by a scalar that is going to be K. Okay, similarly you have one more thing. In this is a little bit different when compared to the other two. In this one, you are going to find out that you are going to add some number from some other row. So if I have the first row, okay, I'll just write an example down. R1, first row I am getting converted into R1 plus 2 times R2. So I need to multiply 2 times the element that is present over there. Okay, I'll just show the examples later. So it is going to be Ri plus K times Rj. J refers to some other row when compared to I. So similarly, you can also have Ci becomes Ci plus K times Cj. This much we found out. So we have an example and I'm going to do everything with that. Okay, the first one is you need to change this row. So I'll consider R1 is going to get interchanged by R2. This becomes 3, 4 and 1, 2. Or if I change the columns, if I change the column, that is C1 is getting interchanged to C2, it is going to be 2, 4 and 1, 3. I hope how you understood that. So you are just going to interchange those two columns. Even if you have one more column, maybe you are having a third column and you are getting a square matrix of order 3, you are not getting bothered about the third column. You are asked only to interchange first and the second column. That is the thing you need to do. Okay, that was the first one. The second one is about multiplying every element of a given line by some integer. So if I consider R1 I'll consider, okay, it's not any real number, any scalar. So maybe I'll consider it to be half. So the R1, I'll take R2. Why R1 only? R2. R2 maybe you're going to divide it by half or multiply it by half. That's what you are going to get. So similarly I'll do here also. So C2 is going to be 2C2. Okay, I'm going to multiply 2 to every element that is present in the second column. So what we are going to get here? Many times this becomes very irritating when you are going to get the next exercise. Okay, so you have this second column is going to change. You are not at all bothered about the first column, first row. So it is going to be as it is. You need not worry about that. You need to just keep it as it is, and now you need to multiply half to this 3. 3 becomes 3 by 2 and 4 becomes 2. This is what the operation says. That means that only the second row elements should be multiplied by half or divided by 2. So maybe I'll write this one here. Here also only C2 is going to change. So I need not change this thing. So it is going to be 1 and 3 itself. I need to multiply every element that is present in the second column by 2. So this becomes 4 and 8. This is what the elementary transformation says. So now we have one more example, one more rule that you are going to learn. Maybe I'll use a simpler one. So I'll write R1 becomes R1 plus half times R2. And this one is C1 becomes C1 minus half times C2. Okay. So one more thing you need to take care is that you cannot include C and R in the same operation. That means that you can't write C1 gives C1 minus half R2. So that is not possible. You need to take only C together and only R together. So whenever you find, you're going to find in one case, you can use either row or column transformation in case of a matrix. If it is going to be determinant, that is a different case. We need to think about that later, not now. So you are going to have a 2 by 2 matrix in both the case. So what is going to change here? First of all, you need to take care because you have an R2 here. Is R2 going to change? R2 is not going to change. So it is going to remain as it is. R2 is going to remain as it is. So I need to bother only about the first row. If I need the first row, 1 plus half times R2. That is the element that is present in the same column but in the row R2. So this becomes 1 plus half times 3. Half times 3 is 3 by 2. 3 by 2 plus 1. 3 by 2 plus 1 is 5 by 2. 5 by 2 we got. Okay. Next you have R1 plus half R2 again. So that is 2 plus half times 4. 4 is present in the same column of the but different row. That is the second row. So that is going to be 2 plus half into 4. Half into 4 is 2. So 2 plus 2 comes to be 4. This is what you are going to get here. Okay. Next you have here this one also. So here you can just take care that K can be either positive or negative. So first of all we need to take care that C2 is not going to change. Therefore C2 remains there itself. So it is going to be 2, 4. So now C1 is going to change, right? So C1 becomes 1 minus half times 2. Half times 2 is 1. So 1 minus 1 comes to be 0 here. Okay, now we have 3. 3 minus half times 4. 4 is present in that same row but the next column. Therefore, you are going to have 3 minus half of 4. Half of 4 is 2. 3 minus 2, that comes to be 1. This is the thing you're going to get. Okay. That's it about elementary transformations. So what you're going to learn now is about invertible matrix and inverse of a matrix. So it is based on the binary operation, that is matrix multiplication. So if you need to find the inverse of any state, any matrix, so I'll consider A as a matrix. We knew that A star B should be B star A, that should be equal to the identity element. Here the identity element is the identity matrix, that is I, and if A star B should be equal to B star A, star I mean multiplied here because it is about multiplication. So if in such a case A into B is going to be I, AB is equal to BA is equal to I, only in such a case you can tell that B is the inverse of A. This is same notation as in the relations and functions we learned, A inverse. Okay. I did not explain much about this because I have explained in relations and functions. Similar way here it is going to be. The main thing is how we need to find the inverse. Okay, first of all, this much we find out. So we need to know here that if B is equal to A inverse, that means that only square matrices can have the inverses. Only square matrices may have only square matrices may have the inverses. Okay, that much you can make out, that only square matrices can have. So even in the square matrices there are some of them which cannot have the inverses, that you will learn in the next chapter in determinants, why they cannot have and all. So only some of the square matrices can have the inverse of that matrix. Okay, that much thing we found out. So we can find that B is equal to A inverse. So we also know by the properties in the relationship functions that the inverse is going to be unique for that. So one of them cannot have more than one inverses. So if there is one proof also for that given in the textbook. I think that is not so much important. There is one more property that is very important here, that is AB whole inverse is equal to B inverse into A inverse if A and B are of same order. If I consider of the same, A and B are the square matrices of same order, then I can tell that AB whole inverse is going to be B inverse into A inverse. Okay, there is also another proof given in the textbook. I think that you can refer by yourself, or maybe you can just without that doing you can do. Okay. The next part is finding the inverse using elementary transformations. So these two things we are going to combine. So now we understood what is the invertible matrix that can be having an inverse. So inverse of the matrix is such that if it is going to be the product that is multiplied by that, you are going to get the identity matrix. That much we found out. Now we are going to use the previous topic, that is elementary transformations or elementary operations, that you are going to use to find the inverse of the matrix. This is very very important. Many a times it's come to be the 6-mark questions. Okay, now we are going to learn how to find the inverse of a matrix by elementary operations. So first of all, we know that only square matrices may have inverses. So what is the condition for finding? Maybe there are going to be so many things. So first of all, we'll think about what is A. I need to find the inverse of A using some method. So for that, first of all, I need to take A is equal to AI or A is equal to IA. Okay, these two are different. They are not the same. Don't think that they're going to be the same. These two are different. So if you are considering this, so when you using the matrix multiplication, you consider the rows of this. You consider the rows of this and columns of this. So this is about column transformation. Because here you are having the identity matrix I that is going to have the columns. Okay, then here but you have I considered for rows and A considered for columns. Therefore this tells that we need to use the row transformation. Better we'll use the row transformation. Whatever it is, maybe you can use a column, but it is easier to compare row transformation. So we'll see what we're going to get. We'll take a smaller one, that is a 2 by 2 matrix first, and then we'll go to the next, that is 3 by 3. 3 by 3 is a very long method. You need to be patient while finding the inverse there. Okay, now we have a question. This is one of the questions from the exercise itself. So whatever it is, we are going to have a 2 by 2 matrix. So first of all, we'll mark this as A. So I'm going to use row operations. Therefore, I can write IA. So we'll write the expanded form. Maybe because it is going to be a long method, I'll write it in 2 columns now. So I'll write A is equal to IA. That is 2, 5, 1, 3 is equal to 1, 0, 0, 1 into A. This A you are not bothered about. That is whatever it is. So you are going to convert this one into the inverse, and this is going to be the identity. So you know that A inverse into A is going to be I. That's why you are converting this into I and this into A inverse. So at last you can find A inverse. So first of all, we are going to use the row operations. For that, now that is the row operations. So if it is a row operations, you need to go in the anti-clockwise direction. So for better results, maybe you can try if you want. It is going to be the clockwise also. So anti-clockwise direction is going to be very easy. So first of all, I need to take this and convert it into 1. So either I can do half, multiply that row by half, or I can subtract from this. Subtracting is a better option because if I do divide by half, you are going to get half here and it becomes a very bigger problematic. So first of all, I'll do R1 becomes R1 minus R2. Therefore, it is going to change to, so the second row is going to be the same in both the cases. First of all, I'll write that. Okay, now 1 minus 0 is 1, 0 minus 1 is minus 1. Minus 1 we got. So now we have 2 minus 1 is 1. Then you have 5 minus 3, that is 2. So similarly, now we want a 0 here. We need to form 1 0 0 1. We need to form this from this one. So 1 we got. So we need next one 0. So for that we'll take R2 becomes R2 minus R1. So R1 is going to remain like that, and here also 1 minus 1 A. So why did I take this? Because this you have directly 1, and 3 minus 2 also becomes 1. So this is over. These two I can do it in one step itself. So this becomes 1 minus 1 is 0, 3 minus 2 is 1. Okay, then you have one more thing here also, 0 minus 1. 0 minus 1 becomes minus 1. 1 minus of minus 1, that is going to be 2. This much we got. What is going to be the next one? I'll write that once more here, otherwise I'll miss out something. 0 1 is equal to 1 minus 1 minus 1 2 into A. Okay, so these much I got. I need only one more step for completing this answer. Okay, till now we got these three, that is 1 0 1 we got. Now we have one more 2 we need to convert it into 0. For that we need to do something. I cannot divide it by something in order to get that. Either I can multiply by 0, that is not permitted however. So if so the first two operations cannot be successful, I need to use the third operation. So it is going to be R1 to R1. For that I need to subtract something because all the numbers are positive. It is going to be minus 2 times R2. Okay, this much we got. So now we will apply that. So this is going to be 1 0 1 because this is not bothered, and this is going to be 0. So you have minus 1 and 2 here. So it is A. So here what we are going to get? 1 minus 2 times minus 1. So minus 2 times minus 1 is 2. So 1 plus 2 is 3 here what you are going to get. Then you have here minus 1. So minus 1 becomes minus 1 minus 2 times 2. Minus 1 minus 2 times 2. So it is going to be minus 5. Therefore you got I is equal to B into A. Therefore B is equal to A inverse. This is some B, some random B. So B is equal to A inverse. Therefore I can tell that A inverse is going to be 3 minus 5 minus 1 2. This much we got. Okay, if you have a doubt you can just try and see, multiply and see, you are going to get the correct one, that this is going to be the inverse. Okay, next we are going to start with the exercise. Okay, fifth question you have. So all 1 to 14 questions in this exercise, that is 3.4, you are going to find the inverse. So most of them are having inverses and you find it very simple. So I'm going to do only 2 or 3 out of them. So the fifth question here it is given as 2174. So maybe I'll use the column operation and show how we need to use the column operation. So I'll be writing now, that is 2174 is equal to A into 1001. Okay, we need to get 1001 for this side. So in order to get that, 1 is here. So 1 you have it in the right hand side. So I'll do C1 interchange with C2. This forms 1427 is equal to A into 0110. Okay, it's going to form like this. So now, since it is a column operations, I need to use the clockwise direction. That is, I need to start from this 2 and end up here. Okay, so first of all I need to use R1. So R1 is, no, not R1, here again I'm confused. It is going to be C2, right? C2, 2 belongs to C2, so C2 becomes C2 minus 2 times C1. So I'll consider how it is going to be. So the first column is going to remain the same, and A is into, here also first column is going to get the same. So 1 minus 2 times 0 is 1 itself. 0 minus 2 times 1 is minus 2 here. Okay, then you have what you need to do here. 2 minus 2 times 1, that is 0 here. You wanted a 0, that's why you did that. So 7 minus 2 times 4, you are getting minus 1. So now we are multiplying the second column by minus 1. So I consider it to be K into C. So this becomes 1 4 0 1 is equal to A into 0 1 minus 1 2. This much you get. So next operation we are going to do is based on this 4. So 4, you need to consider it with C1. So 4 belongs to C1, so you need to change C1 in order to get that. So you need to consider 4 minus 4 times the C1. So C1 minus 4 times C2. So because 1 is here, so I want 4 minus 4. In order to get that, I'm doing like this. So at last you are going to get 1 0 0 1. This much we got, and you have A into, the second column is going to remain the same. Second column is going to remain the same. The first column becomes 1 C1 minus 4 times C2. So that is 0 minus of minus 4 times, that is 4. So you're getting 4 here. Okay, then you have 1 minus 4 times 8. Minus 4 times 8 is going to be minus 7. So I is equal to A into B. Therefore B is equal to A inverse. Therefore A inverse, I can write it to be 4 2 minus 7 minus 1. Okay. You will learn more about finding the inverse faster than using the elementary transformation in the next chapter, where you will find what is adjoint of the matrix. Okay. Okay, now we have your 12th question. So many questions are very easy. So this is a 12th question. So now we have, maybe I'll use a row transformation here. So I can write it to be IA, or 6 minus 2 minus 3 1 is equal to 1 0 0 1 into A. Okay, now I'm going to use the row transformations because this is on the left side and A is on the right side. So I need to go it in the anti-clockwise direction. Okay, so first of all I need to make this into 1. In order to do that, I don't have anything. That's why I'll divide it by 6. So R1 becomes R1 by 6. I do not have any other option. That's why I'm going to divide by 6. Otherwise it would be very difficult for further. So it is going to be minus half minus 2 1 is equal to 1 by 6 0 0 1 into A. This is 0 by 6, however is 0. So minus 3 by 6 is minus half. 6 by 6 is 1. So now we have your R2. For converting this into 0, I am going to add that by 2 times the R1. So R2 is converted into R2 minus, or I'll add, I think, yeah, plus 2 times R1. So this becomes 1 minus half is as it is, and here also 1 by 6 and 0 is as it is, and you get 1A. So minus 2 plus 2 is going to be 0. 1 minus half into 2 is 1. So 1 minus 1 is 0. Okay. Here is however 1 by 3, and here you have 1. Okay. See, you have one more thing here. You are going to get 0 here in the entire row. 0 in the entire row or column. If you consider maybe another case where you are going to get entire column with all the zeros. So in such a case, you can tell that A cannot have any inverse. Cannot have inverse. Or I can tell that it is not invertible. Not invertible. This is the point to be noted. Point to be noted. If it is a 0 in the whole column or the row, it cannot have an inverse or it is not invertible. Okay. So that's why the A that is present in the 12th question does not have any inverse existing. Next we'll move to the 14th question. Okay, now we have a 14th question. In the 14th question, I'm going to use the row operations again. You have 2, 1, 4, 2 is given here. Okay, and now we have what you're going to get is, so this one I need to convert it into 1. So maybe because I'm going to use a row operation, or shall I use column operation? So maybe I'll use column operation here. That makes me better over here. Okay, so I'll use the column operation. That is A into I. That is A into 1, 0, 0, 1. I'll make the column here. Okay, now first of all I'll interchange C1 and C2. If I interchange C1 and C2, I'll get 1, 2, 2, 4 is equal to A into 0, 1, 1, 0. Many times interchanging doesn't make a difference. I can write whatever I want. So now I'll take C. So since it is a column operation, I need to go it in the clockwise direction. That is, I need to start from this 2 and go in the wrong direction. So if I need to convert this into 0, I need to make C2 minus 2 times C1. So for that, 2 minus 2 becomes 0. 4 minus 2 times 2, that is 0. That is equal to A into 0, 1. Then what you're going to get here is 1 minus 0. Okay, 0. 0 minus 2 times minus 2. So again you find one more case, that is the column has all the zeros. So that is going to be the having no inverse. Okay, that's it for the 2 by 2 matrices. Many times 2 by 2 matrices doesn't come. So maybe 1 mark question or 2 mark question. So when you consider 6 mark question, it comes the next type of questions, that is the 3 by 3 matrices, where you have at least 7 to 8 steps. Here we had maximum of 4 or 5 steps. There we'll have 7 to 8 steps at least. Okay, next we are starting with the 16th and the 17th question. Now we have the 16th question here. That is a 3 by 3 matrix. So we need to convert this one into the identity matrix, that is like here. So at last we need to get that. So maybe I need to rub in between. You can see that also properly. So here first of all it should be 1. So it has B1. So since it is a row operation I'm going to use, I need to go it in the anti-clockwise direction. That is, I need to start from here and go till here. So next is minus 3 here. Minus 3 I need to get it in some form. So I'll take R2 becomes R2 plus 3 times R1. So this is going to be 1, 3 minus 2, 2, 5, 0 as it is. Then it is equal to 1, 0, 0, 0, 0, 1 as it is. Then A. Okay, this much we got now. So we need to add this. Minus 3 plus 3 times this is 0. 0 plus 3 times that is 9. Then you have minus 5 plus 3 times minus 2. That is minus 11 you are going to get here. Okay, this much we got. So 0 plus 3 times that thing is 3 here. Then the remaining terms become 0 because it is 0 1. So they remain as it is. So next you have this 2. For that we take R3 becomes R3 minus 2 times R1. So this becomes 1, 3 minus 2, 0, 9 minus 11. Then you have, so maybe we'll take the right hand side first. 1, 0, 0, 3, 1, 0 and A. So minus 2 times R1. So the 0 minus 2 is minus 2. 0 minus 0 is 0. 1 minus 0 is 1. So this means whatever is here, it's so easy. So 2 minus 2 times this is 0 here again. So 5 minus 2 times 3 or 5 minus 6 is going to be minus 1. Then you are going to have here 0 minus of minus 2, that is okay, minus 2 into minus 2, that is 4 you are going to get. Okay, this much we got now. So what is the remaining thing? This one need to convert into 0. For that, maybe I think I can I can do the operation similar one. So it is going to be R3 converted into R3 plus 1 by 3 times R1. Okay, 1 by 3 times R1. So I'll get whatever I'll get here. So maybe 1 3 minus 2 0 9 minus 11 and 0 plus, so maybe I cannot use that, because if I consider this is going to be 0 plus half. So this 0 is disturbed over there. So we need to consider only the second one, because there is one 0 here. I can consider only the second row, so I cannot go with the first row. So it is going to be R3 minus 1 by 9 times R2. Okay, 1 by 9 times R2. So we'll see what we are going to get here. So the first and the second row is going to be the same, first and second row. So what is the third row is 0 minus 0 is 0. Then you have minus 1. We need to add, right? So I'll make it as 0 such that you need to get 0. Then you have 4 plus 1 minus 1 by 11 by 9. 4 minus 11 by 9. So 9 4s are 36. 36 minus 11 divided by 9, that is going to be 25 by 9. 25 by 9. Yeah, 25 by 9. I'll write that 25 by 9 here. 25 divided by 9. So now I need to multiply. So this much is there. So you have 1 0 0 3 1 0 into a. So since this one is going to be 0, this is not going to change. Then 0 plus 1 by 9 times this one, so it is 1 by 9 here. So later you are going to have minus 2 plus 1 by 9 into 3. Minus 2 plus 1 by 9 into 3, that is going to be 1 by 3. So 1 by 3 minus 2 is same as 1 minus 6 divided by 3, or minus 5 by 3. Minus 5 by 3 is the thing what you are going to get. Okay, that much is over now. So those many zeros we got. Now we have to work out with only 5 more things. So I think 5 more steps are required. What we are going to do now is we are going to multiply it by 9 by 25. So we'll convert R3 to 9 by 25 R3. 9 by 25 R3. Therefore the first and the second column is going to be the same. That is 1 3 minus 2 0 9 minus 11, and then you have 0 0 1. Okay, then the first and the second column is going to be the same, 1 0 0 3 1 0. And now minus 5 by 3 into 9 by 25. So 5 5 cancel. So now we have 3 by 5. 3 by 5 is what you are going to get here. Minus 3 by 5. You have one minus, right? So minus 3 by 5. Then 1 by 9 into 9 by 25. 9 by 25, it is going to be 1 by 25. 1 by 25 here. Then at last you have 1. 1 becomes 9 by 25. This much we got. So now we'll see what we are going to do next. So the next step is to convert this into 0. Okay, we need to convert that into 0. In order to do that, we'll do 2 operations together. Yeah, we'll do 2 operations together. Okay, first one operation is enough. R2 becomes R2 plus 11 times R3. 11 times R3 in order to get rid of that 11. So it is going to be 1 3 minus 2 0 9 0 0 0 1 is equal to 1 0 0 minus 3 by 5 1 by 25 9 by 25 is as it is, and I'm going to get A over there. Okay, now we are going to add 11 into R3, so you are going to get 99 by 25 here. Then here you are going to get 1 plus 11 by 25, that is 25 plus 11 is 36, so you are going to get 36 by 25. So now we are going to get one more thing, that is 3 plus 11 into minus 3 by 5 is what you are going to get. 3 plus 11 into, so it is going to be 20, 15. Okay, we got one more thing. Now 3 plus 11 times R3. So since I had divided by 9 by 25, that was the biggest problem. So you're going to get so many irritating things now. Okay, so 3 plus, so this is going to be 15 minus 33 divided by 5. Yeah, 30. Yeah, so you're going to get what is 15, 33 minus 15, that is 18. Yeah, minus 18 by 5. Minus 18 by 5 is what you're going to get. So this much we got now. The next step is converting that 9 into 1. In order to do that, now I'll convert R2 to R2 minus, no, 1 by 9 R2. So this becomes 1 3 minus 2 0 1 0 0 0 1. This much we got here. Okay, now this is 1 0 0 minus 3 by 5 1 by 25 9 by 25 into A. So it is going out of the board now. Whatever it is, divided by 9, this becomes minus 2 by 5, this becomes 4 by 25, and this becomes 11 by 25. Okay, 11 by 25, this much we got. So now two more steps remaining. So I need to convert this into something. So I'll take R1 becomes R1 plus 2 times R3, because you have a 3 here, 1 here. So this becomes 1 3 0 1 0 0 0 0 1. Okay, then you have here minus 2 by 5 4 by 25 11 by 25 minus 3 by 5 1 by 25 9 by 25. You need to be careful when it comes to be so many numbers now. Okay, 1 plus 2 times R3. 2 times R3 is minus 6 by 5. Minus 6 by 5 plus 1, that is going to be minus 1 by 5. Minus 1 by 5. Okay, next is what you are going to do is, yeah, this one you need to consider. So plus 2 times R3. 2 times R3 is 2 by 25. 2 by 25, and this is going to be 18 by 25. 2 by 25, 18 by 25. Next, one more step, we need to remove that 3. We need to remove that 3. In order to remove that 3, we need to subtract it, that row, that is row R2. R2 becomes R2 minus 3 times R1, right? R1 becomes R1 minus 3 times R2. Therefore, it becomes the identity matrix at last. Somehow it became the identity matrix. Okay, let it do whatever. Minus 2 by 5, 4 by 25, 11 by 25. Now A, then you have minus 3 by 5, 1 by 25, 9 by 25. This much we got. Okay, here you find out that it is R1 minus 3 times R2. That becomes minus 1 by 5 minus 3 into 2 divided by 5. That is going to be minus 1 minus 6. That is, yeah, minus 1 plus 6, right? Minus of minus is going to be plus. So it is going to be 5 by 5, or I'll let it be 1. So now you have 2 by 25. 2 by 25 minus 3 times 4 by 25. 4 by 25. So 25 is here. So now we have 2 minus 12. 2 minus 12 is minus 10. I can divide by 5. So it comes to be 2 by 5 minus 2 by 5. Then you have one more number, that is 18 by 25. 18 by 25 minus 3 times 9 by, not 9, 11. 11 by 25. So that is going to be out of 25, 18 minus 33. 18 minus 33 is going to be 15, I guess. 33, 18, 5, 15, yeah. 15, that is going to be minus 15 divided by 25, that is 3 by 5. So it is going to be minus 3 by 5. So this is the inverse. Somehow we got this inverse after so much time. So I did a series of steps. You can make out how it was so lengthy. So it is going to be at least a 6-mark question for this. So we'll do the 17th question now. Okay, you have your 17th question. This is the last, and the next one is the MCQ, however. So you have your question. So it is going to be IA, right? It is of the form A is equal to IA. So let me use the row operation here itself. So it is going to be R1. I'll consider it to be half times R1. So first itself I'll multiply. So it is going to be 1, 0, minus half, 5, 1, 0, 0, 1, 3 is going to be. So that is going to be half, 0, 0, 0, 1, 0, 0, 0, 1 into A. Okay, this is the row. So this one is over. Now I need to consider R2. R2 gives R2 minus 5 times R1. So it is going to be 1, 0, minus half. 5 minus 5 times is 0. 1 minus 0 is 1. 0 minus, so it is going to be 5 by 2 here. It's going to be 5 by 2, and this is 0, 1, 3 as it is. Then you have half, 0, 0 and 0, 0, 1. Then you have in the middle. So this is going to be 0 itself. So what is going to be here is 1 minus 5 times. So it's going to be 1 itself. So now we have 0 minus 5 times half. So it is going to be minus 5 by 2 here. Minus 5 by 2 here. It's going to be A now. So now the remaining one is here. So let me take R3. R3 becomes R3 minus R2. R3 becomes R3 minus R2. So it forms 1, 0 minus half, 0, 1, 5 by 2, 0, 0. 3 minus 5 by 2 is half. Yeah, right? 3 stands for 6 by 2. So 3 minus 5 by 2 is half. So I'll write here also half, 0, 0. A minus 5 by 2, 1, 0. Then you need to do R3 minus R2. So it's going to be 5 by 2 here. Here minus 1 and here 1 itself. Okay, this much is the thing. So the next step is going to be based on this. So I'll consider R3. R3 becomes 2 times R3. Then it is going to be 1, 0, 0, 0, 1. This much is over. And this is also all right. And you have only 5 by 2 and minus 1 by 2 left here. So this is half, 0, 0, A here. Then here minus 5 by 2, 1, 0. Minus 5 by 2, 1, 0. Then I need to multiply everything by 2. So it's going to be 5, minus 2 and 2 here. Okay, this much we got. Now the next step is about this thing. So we have R2. R2 becomes R2 minus 2 by 5 times R1. Sorry, 5 by 2 times I1, R1. 5 by 2 times R1, not R2, R1, R3. So it is going to be 1, 0, minus half, 0, 1, 0, 0, 0, 1. Then you have half, 0, 0. This is a simpler question than the 16th one. 16th one was very hard, I think. So this is looking a little bit easier. So now we have minus 5 by 2 here. Minus 5 by 2. Minus 5 by 2 into 5. Okay, what does it tell? That is minus 5 by 2 minus 25 by 2. Okay, 25 plus 5 is 30. Here you have 5 minus 2 and 2. That is not going to change. So minus 5 and it's going to be 30. So it will be minus 15 here. Minus 15. Then here 2 more things are remaining. So 1 minus of minus, that is plus 5 by 2 into 2. Therefore it is going to be 5. 1 plus 5 is 6. Then you have 0. 0 minus 5 by 2 times 2 is minus 5. This much we got now. This much is alright. So next step is only about this thing. So that is R1. R1 I am going to change it to R1 plus half times R3. So it is going to be 1 0 0 and 0 1 0 0 0 1. This much we got. Then we have, so we are bothered only about R1. The remaining is kind, right? So it is going to be like this. 5 minus 2 2. This much is okay. The next one we are going to get is about the R1. R1 plus half times R3. So half plus 5 by 2. Half plus 5 divided by 2. That is going to be 6 by 2 or it is 3. Okay. Then you have 0. 0 plus half into minus 2. That is going to be minus 1. Then you have 0 plus half times 2. That is 1 into A. Therefore, this becomes A inverse. Therefore, you can write that A inverse is going to be 3 minus 1, 1, minus 15, 6, minus 5, 5, minus 2, 2. Okay, this is it all about the exercise 3.4. At last, you have the question, that is 18th question MCQ, wherein you are asked to find, it is relating to the matrix multiplication itself. Okay, let me half I'll rub and leave. So the question says A and B are inverses of each other. A is B inverse and B is equal to A inverse. That is the meaning that A and B are inverses of each other if and only if. What is the condition? Out of these conditions, there is AB is equal to BA, AB is equal to BA, AB is equal to BA is equal to 0 matrix, and you have AB is equal to 0, BA is equal to identity matrix, or AB is equal to BA is equal to identity matrix. So if you are just thinking about relations and functions, forget about matrices. Thinking about relations and functions where we learnt about the inverse existing, it should be A star B is equal to B star A is equal to the E. E is the identity. So similarly, what is going to be the condition is the fourth one. Fourth one says A into B should be equal to B into A is equal to the identity matrix. So this is going to be true for that. Okay, that is it. So we are going to move on to the miscellaneous exercise. Now onwards, we think about another type of question, that is the questions based on principle of mathematical induction that we learnt last year. It was just about a lengthy method you are going to use. That's going to come again in this chapter also. Okay.